And this is video 9 of the astrophysics unit. And in this video, we're going to be looking at more ways to measure distance. Last time, we looked at parallax and something called spectroscopic parallax. This time, we're going to be looking at a special kind of star called a Cepheid variable. Now, variable stars are stars that get dimmer and brighter with time. A Cepheid variable is a particular kind of variable star. And the way we recognize them is that the variation is periodic, meaning, say, right now the star is bright. And over the next, say, 2 weeks, it dims and gets bright again. And then it does exactly the same thing in the next 2 weeks and the 2 weeks after that, and so on. So it's periodic variation. The other thing about Cepheid variables is that the brightness rapidly increases and then slowly decreases. So if you were to graph the brightness of a Cepheid variable, it would look something like that. Rapid increase, slow decrease. And the period would be the time between minima or the time between maxima. The cause of this is that Cepheid variables expand and contract. When they expand, they get brighter because the surface area increases, and when they contract, they get dimmer because the surface area decreases. Now, the way we use this for distance measurements is that if you look at Cepheid variables in our galaxy, where we can use parallax or something to get their brightness, or to get their distance, it turns out that the luminosity of a Cepheid variable is related to the period. There's a graph in your textbook. It's on page 350. But basically, if you do a log-log plot of the period, and the luminosity, you get a straight line. And if you know what the period is, that's period, not temperature. If you know what the period is, you can figure out what the luminosity is. And then, if you know the luminosity and the brightness, you can find out how far away it is. So let's look at an example. You've got a Cepheid variable located in the Andromeda galaxy, has a period of 20 days, and a brightness of 2.73 times 10 to the minus 16 watts per meter squared. We want to find out how far away that galaxy is. So first off, if we look at the graph, remembering it's a log scale graph, so it's a little bit weird to read, but a period of 20 days corresponds to a luminosity of 6,000 times that of the sun. Which works out to be 2.34 times 10 to the 30 watts. And we've got the brightness. Remember, L equals 4 pi d squared b. D equals the square root of L over 4 pi b. Plugging numbers in. And we find that the distance to this particular Cepheid variable is 2.61 times 10 to the 22 meters, which is 2.76 times 10 to the 6 light years. So that tells us this star is about 2.75 million light years away. Now, what makes this really, really useful, because finding the distance to this particular Cepheid is not terribly important, but because it's in another galaxy, this tells us approximately how far away the Andromeda Galaxy is. And it is quite far, on the order of several million light years. And this is called a standard candle. What that means is a star where we can determine the luminosity without knowing the distance. In the case of the Cepheid variable, you use the luminosity, or you use the period to get the luminosity, and then you use the luminosity and the brightness to calculate distance. You should be able to describe what a standard candle is. Cepheid variables are the most important kind, but there are others as well. Type 1a supernova are another important one. And a supernova, remember, is basically an exploding star, but there are particular types of supernovae. And type 1a, which is, you don't need to know the details of it, but the light curve from a type 1a supernova looks about like that. If you look at its luminosity and the temperature. And it turns out that there's a very predictable relationship between the time to the maximum brightness and the luminosity. And so you should know that type 1a supernova are another example of standard candles. You don't need to know the details of it, but you should know that it's easy to calculate their luminosity without knowing how far away they are. There are other standard candles out there as well. There's probably 10 or 20 different kinds that astronomers use. The most important are Cepheid variables, which are also the only one that's likely to show up on the IB exam. And then type 1a supernova are important as well.